All right, so we're going to continue finishing up example number 1. So let's just go through A again. Which miles per gallon ratio did Ms. Perez plot most frequently? So what do we get for that? Jackson?
26 and 31.
Yeah, 26 and 31 were used how many times each? 3. So they're both used the most 3 times each. So 26 and 31. All right, B. What are the highest and lowest MPG ratios? Yep. Yeah, and you can see on your stem and leaf plot, it's the first number and the last number. So that's really easy to pick out. What's cool about that, well, sorry, you might be thinking, but Mr. A, I could have found that out for B just by looking at that set of points. Yeah, you could have, which is fine, but now you can see that and other pieces of info, which we'll answer in C and on. So C, each line of the stem and leaf plot represents an interval of the data. In which mileage interval did Ms. Perez find the most cars? So which one of those intervals has the most data points? Lucy?
20 to 29.
Yeah, you would say just 20 to 29 interval. You can put INT, period. 20 to 29 interval for C. All right. How many cars have a ratio of between 20 and 39? You're looking at the 20 to 29, the 30 to 39, those two intervals. How many cars, Matt? 15 of them. So you count 2, 4, 6, 8, 10, 12, 14, 15. You have your 15 cars. All right, and this is a question where we're starting to look more subjective. That means it's an opinion, but it has to be an informed opinion. All right, so on E, if you were Ms. Perez, so it's not just one answer. You must think like this. No, but if you were Ms. Perez, which cars might you investigate more closely, and then why? Okay, so I need you to give me which categories would you investigate, and then why. You have to remember why Ms. Perez is even doing this. All right, Jack?
I would say the 50 to 59 interval, because that's the highest miles per gallon, and basically the whole search is which ones, or she got all of the cars that she liked together.
Good. That's a key piece.
She basically just put the miles per gallon on them, and that was the highest, so she probably went the highest.
Okay, good. So, like, definitely looking at the higher end. So 50 miles per gallon, that's a good one. Does anyone have a different answer? Want to add to that? Because that's not the only correct answer. That's a good answer, but there are others. Yep.
Probably the last 2 lines, because you don't really want to, like, only have one choice.
Okay, so maybe you want more options. And Jack, you actually brought something up. Didn't she like all these cars? It says she got the miles per gallon of all the cars she liked. So even the one with 12 miles per gallon, 12 miles per gallon, she liked it. So like if she could get it, she would. But 12 miles per gallon, not economical. The last 2 ones, Nate, that's a good idea because it gives you more selection. But if it's like a company car or if the company reimburses her, why does it even matter? Why didn't she just go for that nice sports car that gives her a few miles per gallon, but man, looks awesome, rides great? Well, it might not be her deciding. Maybe it's the company. The company saying, all right, what car should we give our employees? Maybe we'll give them the 30 to 40 range because that's economical, yet it looks great. It's kind of like a win-win. But for Ms. Perez, I would say 40 to 50 is a good range there. So you see how it's subjective? If I were Ms. Perez, I would look at, okay. And that's good as long as it has reason. Okay. This is what I want us to do. Look at example number 2. We are not going to do that stem and leaf plot. That's a tough one. But we are going to talk about it because I need you to know what to do if you had to do a stem and leaf plot for example number 2. So we are on page 27, and I'm looking at the top, and that's example number 2. All right, someone read for me the scenario there. Emery? Okay, so first you're going to have to make a stem and leaf plot. Okay, what you have to do first is think, what's the smallest number, what's the largest number? So does anyone know what the smallest number in that set of data is? Lucy? 98. 98 is the smallest one. All right, what is the biggest number?
159.
159. Looks like it's the biggest number. Okay, you guys could do that pretty easily. So what should my stem and leaves be? So I'm not going to do the whole stem and leaf plot, but I am going to talk about how to start it up. Because if we can start it up, I'm sure you can finish it out. So I'm just going to do like the beginning part. This is my stem, and these are my leaves. So what should be the stem? Do you guys remember what we have to think of to decide what our stems are? Yep.
Place value.
What about place value? Like to find the stem specifically?
Well, so basically, it's mostly the tens values, but in the hundreds and the ones.
Okay, you have to look at the highest common place value, right? Is that what we wrote down? Okay, but look at these numbers. What's the highest common place value, by the way? Hundreds, but they all have ones. They're all ones. So you think you're going to do like 1 and then all the numbers listed out here? No, but are you allowed to have more than one number in the stem? Like, can you have a double-digit number for stem? Okay, you could do that. So instead of doing just the hundreds, which would not be very helpful, I'm going to do the hundreds and the tens. Okay, the hundreds and the tens. So what's the smallest number? 9. That's the 100 and the 10 would technically be 0, 9, right? 0 in the hundreds, 9 in the tens. But you don't have to write that 0. And then when I have 10, 11, 12, 13, and I think you said 159 was the biggest one. So I'm going to go 9 to 15. Yes, ma'am?
I don't understand how you get the stem, like the stem.
Okay, so the first thing you do is she's wanting to know, how do you find the stem number? How do we find these numbers? Because it is tough. Once you get the stem, by the way, you're basically set. All you have to do now is put the data. All right, what we do is we look at all those numbers in example 2. You see them all? They're all like 100 something, 100 this, 100 that, a couple 98s, 99. What's the highest place value that's most common in that, in those numbers? The hundreds? Do you see how they all have a hundreds digit? Except for 2 of them. That's the highest common place value. But they all have a hundreds digit of 1, right? They're all 100 something. So you could do 1 and 2 and then list all those numbers, but that's not useful. So now we're going to pick the first 2 digits, the hundreds and the tens. Because now I break it down to this, and that's going to be more useful. And you can ask me again how to do that when you get your example. All right, so the first number would be 98 and 99 and so on and so forth, right? Okay, what's missing even if I filled in all these numbers correctly and in order? What would be missing from this stem and leaf plot if I was all done with all the numbers? Yes, ma'am? A key. So how do I write my key on this one? What can I do? Yes?
Like 15 and 9.
15 and 9? What does that mean?
Means 150.
So what does this mean? Well, it means 98. Okay? So that's the key. And then all the numbers would be filled. You don't have to do it. But that's to help you out with example 2. Okay. Example 3. We are going to do this one. And this will be the last stem and leaf we do together. And you'll do one more on your own. And you'll be done. Number 3. Oh my. Can someone read to me what's going on in that scenario? What's example 3 all about? Claire?
You want me to read?
Yeah, go ahead.
Kylie and
Sorry, Kyle and Makito?
to compare boys and girls' height. They measured the height in inches of every student in their class. The data they collected of a similar plot they made are shown below.
Okay, so then they have the heights of the boys and the girls. Okay, this is going to be a back-to-back stem and leaf plot. Back-to-back, what is that? Okay, ready? Let me draw it out for you. We'll call this stem section, and these are the leaves. What 2 categories are we talking about? How are we dividing everyone? By height, and then classifying some as this and some as that.
Short.
Boys and girls, boys and girls. So I'm going to create more space here for myself. We'll put boys, and we'll put girls. Okay, so I'm looking at that data and thinking, okay, I have no idea what the stem's going to be. What's the height? What's the biggest height or the highest height? 70. I see 72. Excuse me, 73. There you go. 73. Highest. What's the lowest height? 58. All right, you got 58. So what did we say? 79? So 58.
Yeah, 73. 73.
Thank you. 58 to 73. Okay, so this is actually not that hard. What do you think my stem's going to be? What place value are the stems going to be? The tens. Yeah. So we have 50, 60, 70. Right? We don't need 40, we don't need 80. So you only have 3 stems. That's nice. And then you're going to look at the girls, you're going to look at the boys. All right, for the girls, okay, we're looking at the girls' side. What are the girls' heights in the 50s? So can you list them off?
7.
Sorry, one person here. Carrick.
57, 59.
57 and 59. That's it?
Yes, sir.
Okay, so we have girls 57 and 59. What about the boys in the 50s? Okay, Nate?
58,
58 and 59. 58 and 59. The girls in the 60s. Ma'am?
60, 61, 61, 63, and 65. Oh, there's another 61, sorry.
Okay, those 3 61s in the girls. And 63, 65.
And there's a 62. And there's a 2.
Okay, that's all right. 2, 3, 5.
And there's 4 in there.
All right, let's look at the girls.
Yeah.
61, sorry, 63 61s, a 62, a 63, a 64, a 65. Okay, who can list them out for me? Just because it's hard for me to. 0, 1, 1, 1, 2, 3, 4, 5.
Yes.
Okay, good. All right, boys, 60s.
Oh, yeah.
Probably. 0.
Go slowly. Don't go too fast. Jack?
There is 60. There is 63, 65, 66, and 69.
Is that it?
Yes.
Okay. All right, and 70s for the girls. 70s for the girls. Yes, Emery? 1 and 2. All right, thank you. 1 and 2. And then for the boys. Sorry. Jenna?
0, 1, 0, 1, 1, 2, 3. Yeah.
Okay, any others? We're all good? Okay, now look what I need you to do. Okay, girls, count up all the numbers I have up here on my board and make sure that's how many girls were represented. Boys, count up all the boys' numbers I have and make sure I have the same number they have. I need you to check me. Because I don't want to go through this problem and then find out, oops, we added some. We're good, boys and girls? All right, good. So now we're done with this. Other than one little. Can't say without saying the word. Go. Key. You can do least to greatest or greatest to least. Yep.
You kind of said door.
Door, okay. And the key, I'm just going to use 6/1 means 61. That's it. And because that's not always clear. So far it's been pretty clear. You're like, okay, mister, I get it. Come on. We can get this. But really, there are going to be some examples. It's not super clear. Yes, sir.
What about it says like 80, like 85?
Say that again.
Would you need another one for the left side for the boys?
No, because you can say, well, I guess like I think you're saying like for the girls you write this, and then for the boys you write like means 58. That's understandable. I would say you could do that, and if you did that, you give people assurance that that's what they're thinking of. But that's a good way to think of it. Okay. All right. Let's answer some questions here. So don't turn the page. What is the height of the shortest boy? Raise your hand. Jackson. Okay. What is the height of the shortest girl? Lucy. 57. All right. 58 for the shortest boy, 57 for the shortest girl. All right. What is the difference in height between the shortest boy and the tallest girl? Shortest boy, tallest girl. Excuse me. What's the difference in height? Nate?
14.
Yeah. What was the tallest girl? 72. What was the shortest boy? 58. So 14 inches difference. All right. What does 6/3 represent?
63. Oops.
So 6 or for you guys -3 means 63, or 63 inches. All right. What is the greatest number of boys who are the same height? What is the greatest number of boys who are the same height? Matt?
71.
How many boys are 71? 2. All right. What about the greatest number of girls who are the same height? Autumn? 61. How many girls? 3. Okay. All right, guys. Here it is. This is my favorite part. We're done answering like which one's used the most. What's the tallest boy? What's the tallest girl? What's the difference? Okay. Here's where I want you to think. What pattern do you see here? What conclusions can you come up with? Our class of boys and girls. Just state any things you can. Support it with the numbers. Don't just say, well, in my experience, blah, blah, blah. No. What do these say? Okay, let's go. Emery? Just something you noticed.
There's 12 members on the girls' side and 12 members on the boys' side.
Okay, there's even number of each. Is that true? Maybe? Okay, I didn't count it, but okay. Even number of boys and girls. What about their heights, though, like comparing their heights? Okay, Jack?
Well, it looks like that there's taller boys than girls.
Okay, there's the tallest boys. Or sorry, there are more taller boys than taller girls.
Well,
So
there's the
like
shortest
5 to
girl,
2.
the tallest girl.
Say that again.
The tallest person is a guy, and the shortest person.
Okay, tallest person is a guy, shortest person is a girl.
By like 1 inch.
Yeah, by 1 inch.
There's more normal people.
There's more.
Like middle people.
Okay, there are more people in the 60s, right? In the 60s, which 60 inches is about 5 feet. So people in the 5 foot range, roughly the 5 foot range.
How old is that?
I don't know. They're probably they might be your guys' age.
Because they're short. Those are probably.
I don't know.
No, they're not. They're short. No, they're short.
Yeah, in their class.
I'm 5 foot.
No. Listen, 5'3". Some of you are. How many of you are 5'3"? Anybody? That? Yeah, these are inches. So 60. Sorry. Yeah, it's not 6'0", 6'1". It's yeah. So 63 would be 5'3", right? So 63. Who's 63 inches? 5'3". Anybody else?
I'm 5'3.5".
Right there. Okay. Who is 5'9"? Anyone 5'9"? Oh, really? Okay, 5'9".
You're not 5'9".
Okay, let me give you I am 5'11 3/4. One of these days I will hit the 6 foot mark. So I'm 6 feet. 6 feet. So I would be 72. I'd be right here for the boys. There's a girl who's taller. I wish. Huh? So that'd be 57, 3 inches. 57 inches? So it'd be 4'9". Are you 4'9"? Sorry?
Barely over that.
Oh, barely. You'll make it, Jenna. All right, guys, listen up so I can get you started on your homework. I want to get you started on your homework, and I'll wait.
Everyone.
Okay. What you need to be able to do is you need to be able to do a regular single line stem and leaf plot and this back-to-back leaf plot because we've done it together. But the main things I want you to get is how to interpret the data objectively. Who's the tallest? Who's the shortest? What's the most common? And subjectively. There are more 5-footers in the girls than there are in the boys. There are more 6-footers than there are 6-footers, for the boys and the girls. You should be able to look at those, objective. And then you should be able to say most of the are, you should be able to make some statements, or you can say they're about the same. Like here, it'd be very easy to say boys are taller than girls. Yeah, maybe. You can definitely say the tallest is a boy, and the shortest is a girl, but someone said just barely, right? Just barely. Okay. All right, so your homework tonight, let me give that to you, is somewhere here.
11 through 16 and...
No, I think it's going to be 11. Yeah, there you go. 11 to 22. There's one more.